Well, welcome back to this session. I'm excited to have an opportunity to talk about now one of our first integrated concept lectures in the course, where we look at how central tendency and variance are related to each other. And of course, in our Emory Roadmap for Data-Informed Health Transformation, this falls under our exploration of variables category. We're looking at, of course, the central tendency and the variance for our variables. We're going to look at how the two measures are related to each other. So measures of central tendency that we're using primarily in this course are the mean and the median, and those show where the middle of our data fall, depending on how we define that middle, whether that be using the median, which is the middle value of all of our data points, or if it's the total of all values divided by the number of observations, which is the mean. Regardless of which of those two measures of central tendency we use, variance describes how similar all the other numbers are to that measure of central tendency, or how different they are. So the larger the variance, the greater the spread there is within our data set. So let's look at these in a little bit of detail. By way of review, we've discussed how mean can be used to look at data. We looked at the total number of hospital discharges and saw that the mean is somewhere right around 400, and I've graphed that here on this histogram for you to see. And we've looked also at median as a measure of central tendency, and we did that on these data using a box plot, and we found that the median value, or the 50th percentile, the middle number in our data set, is 300. Now, when we look at how mean and median are related to each other, on a normal distribution, a normal curve, we have many observations at the top and fewer as we go out to the sides. The mean and the median are equal to each other. And so I'd like to look at how that normal distribution occurs within our data set, so you can see it very practically. This is a graph of the heart failure readmission excess ratio. So this is the number that's used to penalize hospitals in the Medicare reimbursement policies. So the greater the excess readmission ratio, the more poorly the facility is performing in terms of readmissions, as defined by the Medicare and Medicaid hospital performance legislation. So in this histogram, the frequency on the left is the number of facilities, and on the x-axis we have the excess readmission ratio. So when we run the descriptive statistics for mean and median, you can see that the mean is 1.00, which I've graphed here, and the median is 0.99. So in these data, the mean and median are essentially identical. And when that occurs, as we've said, that characterizes a normal distribution. But let's look at a couple of exceptions to the normal distribution. The first of these is when the mean value is actually greater than the median value. So it means that more of the values are occurring on the left-hand side of the x-axis. So there's much on the x-axis, and there are fewer observations on the right side. So the right skew refers to the tail of the distribution, or the parts that are dangling. So let's look at that here with the number of readmissions for heart failure. Here you can see that the majority of the observations occur on the left-hand side of the x-axis, and this tail dangles off to the right. So that's what's called a right skewed distribution. When we run the statistics, you can see that the mean value is approximately 91 and the median value is 66. So the mean is greater than the median, which means that more observations are occurring on the left-hand side of the data distribution, and we have a right tail, so a right skewed distribution. Summarizes it conceptually. Now let's look at a left skewed distribution. Now, in a left skewed distribution, the median value is greater than the mean. So that means more observations are happening on the right-hand side of the x-axis than on the left. And the tail of the distribution, where there are fewest observation, dangles off to the left. So let's see how that plays out. If we look at the number of hospital facilities, or the proportion of hospital facilities who give discharge instructions to their patients, we can see that the mean value for hospital discharge instructions being given is 94%. But the median value is 97, so more observations are happening on the right-hand side of the x-axis, and you have a tail that dangles off to the left. So that is the basis for calling this a left skewed distribution. So how do we interpret variance in terms of the measure of central tendency? Well, this is where things get very exciting. So buckle your seatbelts, get ready to do some thinking, and let's take a look. So the measures of variance are typically related to the distribution of the data, whether it's if it's normally distributed or skewed. So a standard deviation is typically associated with a mean measure of central tendency. So mean and standard deviation typically go together, and median and interquartile range typically go together. So the interquartile range is the 25th percentile to the 75th percentile. So it's where 50% of the data reside, and the 50% of the data that reside right around the median. So let's see how this plays out in our data set. And of course, just by way of review, the variance is the measure of difference in the values from the measure of central tendency. So it shows how diverse the values of the variable are. So if we look at the number of heart failure discharges again, we see that the mean is 400, but the standard deviation is 350. So if we subtract 350 from the mean, we get 50. And if we add 350 to the other side of the mean, we get 750. So the 66% of all observations occur between 50 and 750 discharges for heart failure, with a mean value of 400. Now, when there's a very small variance around the measure of central tendency, it means that the values within that variable are very similar. So let's look at the proportion of hospitals who give discharge instructions. We know that the median number of hospitals giving discharge instructions is 97. And the 25th percentile is 93. So I've plotted that here with a purple dot. And the 75th percentile is 100. So 50% of all hospitals in the United States give between 93% and 100% of their patients discharge instructions for heart failure. So that's a very, very, very narrow range of variance. So the numbers are clustered tightly together and very close to 97%, which is the median. So in summary, the variance for a heart failure readmission with this pattern is, put on your thinking caps, what's the distribution? How would you describe it? For that distribution, what's the best measure of central tendency? And how much variance do we have within these data? So take a second and think about those questions. All right, welcome back. So the distribution of these data are normally distributed. You can see that we're helped here with the normal distribution curve in black, which very closely follows our actual data points. So for a normally distributed variable, both means and medians could be adequate measures of central tendency. And the variance by both standard deviation and interquartile range was incredibly narrow. And the reason for that is because we have so many observations around this mean and median of 1. So there's very little variance between or around that measure of central tendency. So let's take a look at this distribution. I'd like you to think about what's the distribution, what's the best measure of central tendency, and how you describe the variance. So take a break, think about those things, and then come back and join us. So of course, you see here that the majority of the numbers are clustered on the right-hand side of the x-axis. So when most of the numbers happen on the right side, we have a left skewed distribution because the tail dangles off to the left. And so the skew of the distribution is named by the tail, which direction it goes. So when these data are not normally distributed, the best measure of central tendency would be the median, the one that characterizes where half of the values fall above it and half of the values fall below it. And how about the variance? We saw in an earlier slide that the actual variance, as we use the interquartile range, is between 93 and 100. So it's a very narrow band of variance. Let's apply that same thinking to this distribution. What's the distribution? What's the best measure of central tendency? And how would you describe the variance? So pause for a moment, answer those questions, and come back. So the distribution here, we can see that the majority of the values are occurring on the left-hand side of the x-axis. And when that happens, we have a dangling right tail. So this is called a right-skewed distribution. And since it's not normally distributed, it's right-skewed, the best measure of central tendency would be the median, because half of the values occur above it, half below it. And the variance here, as we calculated earlier, is actually incredibly large, because you can see this number here is 1,000 hospital discharges. And so if we look at the interquartile range around the 300 median number of discharges, we have a very large range of variance. So with that in mind, I hope you've had an exciting journey seeing how central tendency and variance are intimately related to each other. And this discussion will form the basis for picking statistical measures to compare, make comparisons and draw conclusions as we move further in the course. Enjoy!